Hello. Is that when hockey starts? Oh, I have a question. Do you know who Mitch Gwast is?
I know of him.
Okay. He's not, at one time he was a coach, wasn't he, or no?
I know he coached, and then he played on the lumberjack.
Oh, he did. Okay. Oh, yeah, he did, because I had the coach of the Lumberjacks in my statistics class when I taught at the tech college.
The old coach of the lumberjacks used to be my neighbor. He's looking down into hockey, and his son's playing D1 in Omaha.
Oh, really? Yeah, Omaha's a good. So Omaha, the college?
University.
Yeah. Good morning, all the Abisters.
Good morning.
And how are you guys? We got a long week, 2 days. Hey, good morning, good morning, good morning. What happened to you?
I fractured right above my ankle on my video.
How did you do that?
Football.
Wow. Okay, I got to do something here. So Abisters, I'm sorry about the change up. It's just with people coming in and out, it's just easier if I always have that link for you guys to click on, and it'll just always be there rather than me trying to figure out who to send invitations to and stuff. So I hope that didn't screw people up. On the pop quiz, what'd you get? 0.7? Yeah, I'm going to go through that. All right, so this is where I'm at. First of all, we got parent-teacher conferences tonight from 6 to 8. I'm available. A lot of people have already scheduled me. That link is in Schoology, and it's a folder called Parent-Teacher Conferences. And inside it's a link that says Parent-Teacher Conferences. So what is that pink thing? Is it pink? Yeah. Yeah, can I see it? And then your t-shirt. What's that a t-shirt of?
A mountain?
Yeah, what mountain?
I have no idea.
It's pretty cool. How do you take a picture of this thing? There you go.
Set that as my lock screen.
Yeah. Well, if you're looking for ideas of how to dress for Halloween, there's an idea. Okay, back to what I was talking about. So anyway, I have your quizzes done. Mr. Lee, are we doing calculus? Are we doing calculus?
I'm trying to connect to my laptop.
Oh, I'll let you do that in a bit, okay?
That's fine.
Okay. Where was I? Oh, I have some homework yet to correct, but your quizzes are done. I'm going to go, the quizzes that we had on Friday, I'm going to go over those tomorrow. Is that okay? Because you guys were out and the gold was in. Is that correct? Okay, so that'll work out better. Now, what had happened was I had ordered this pen, which allows me to grade your submissions through Schoology. However, I didn't get it till after I corrected yours because I corrected yours. I print them off and I corrected them really quick. So I'll scan those and send them back to you so you'll see them. So that'll probably happen tomorrow morning. Okay. And so when you have the quiz, you can pull it up and see how I scored it. Third period, I used this machine for almost everybody else. But from now on in, the other thing is if you have an Apple phone and you send me a picture of your homework, make sure it's a JPEG and not an HEIC or something like that. That's the format that Apple uses to give good quality pictures. However, I can't write and score on that. So what you do is you go to settings, go to your camera and pick the JPEG format and then take the picture. And then if you want to change it back, you can. Does that make sense to everybody? That's about as technology as I can get. Okay. But I am going to go through the pop quiz. The pop quiz wasn't required. That's just for extra credit. And I had it so it was going to release, and it did release at 12:01 a.m. on Sunday, and it was good for 24 hours to 12 p.m. I didn't think it took a lot of time. No, did it take a lot of time?
For me, a little bit, but
You-
I'm not the same.
And you know what? I'm going to say you did really well. I was really pleased with how you did,
Even
even though you wrote me a nice little note on it. And I appreciate notes, okay? Because you're not going to hurt my feelings. My God. You know what? So this is a true story. I had a person when I had him as a freshman, sophomore, and junior, and we had a good communication relationship, but he hated my assignments, and he would scrawl on it profanity and hand it back to me. Okay. I kept them all. And now he's a realtor with children. And I might send him a Christmas present sometime. So that's just something for you to think about. You know, yeah, here's your dad's work when he was in high school. Where was I with this? So anyway, I'm going to go through the take-home pop quiz. Oh, then what happened was I got really nice texts from people that said, hey, there's no Dropbox. I go, oh yeah, I forgot to click that button. And I'm walking with my wife and Rosie out in the woods somewhere, and I can't figure out how to do that on my phone, so you had to wait. So I'm sorry about that. But I didn't think it was, my goal wasn't to make it a difficult thing. So, but that's okay. So I am going to share the screen. And this ended up being 1.2 extra credit points. Okay. So part one was 3/10 of a point. And it says, so I drew this beautiful graph. And it says, suppose the point of tangency is 1, 1, determine the equation of the line tangent to the curve at that point. This format that I gave you is typical AP. Okay, this is how the format is. They'll start off with a problem which they believe is relatively easy. Okay, that may or may not be true. And then they build on it upon after each question. Does that make sense? So this is what happens when I correct. And you'll see it in the quizzes when you get them tomorrow. If you took the derivative wrong, like made you had everything right, and you had a minus x, and you took the derivative, you wrote +1 instead of -1. Okay, let's just say you did that. And then you're supposed to figure out the actual numeric derivative, and so you plug a number in there. Well, your number would be wrong because you should be subtracting rather than adding. Does that make sense? You will not get that wrong. They'll still mark that you did the derivative wrong, right? The actual power rule. But when you did the computation, based on your answer that you had here, that answer is correct, even though the derivative was incorrect. You'll see that's how I score. Does that kind of make sense at all? Abisters, does that make sense at all? So you don't get punished more than once. So anyway, let me take a look at this. So I need, Christian, how many things to make a line?
1,
2. Do you know what the 2 things are?
slope.
And I got the point. So I know right away the equation of my tangent line is going to be x minus 1 plus 1. Now I have to figure out the slope. And up here I have f of x. So f of x is equal x to the negative 1. So the derivative, which gives me slope, is a negative x to the negative 2 power, which is a negative 1 over x squared. And I'm going to plug 1 into here, and I get negative 1. And there's my equation, correct? So if you got that, you got 1/10 of a point. And then some people went down further because they are who they are and said it's the same as that. Now, if this is a positive slope, I can't give you any more points even though these answers are correct. Does that make sense? Because if this is x plus 2, that's a graph going in that direction, and it's impossible to get these answers. Does everybody follow that? I can't give you correct answers when this part is wrong because this is fundamental. So the question is, what is the y-intercept? Well, the y-intercept is where x is equal to 0. So it's simply y equals 0 plus 2, which is 2 or 0 comma 2. What's the x-intercept? Well, that's when y is equal to 0. So 0 equals a negative x plus 2, 2 equals x. So the tangent line, the y-axis and the x-axis all create a right triangle. And the question is, what is its area? Well, it's 2 this way, 2 this way. 1/2, 2 times 2 equals 2. Bingo, you're done, correct? Okay, next page. Now, I change it, don't I? And if you put 2 into that function, you get 1 over 2. And now this is my point. So I'm going to have to determine the equation. I have to figure out slope. Well, the derivative is still going to be this. And when I plug in 2, because that's my x value, I'm going to get a negative 1/4. So the equation of my line is going to be a negative 1/4 x minus 2 plus 1/2. I'm done. Then it says, now they form the right triangle. Well, that's kind of mean because you still have to figure out those intercepts, don't you? Right? So first thing I do is I make x 0. So you get y is equal to a negative 1/4 times a negative 2 plus 1/2. Well, that's 1/2 plus 1/2. It's 1. So right here, this is 1. And if I'm going to, oh, excuse me, this is 1, right? I figured out the y-intercept. Okay. Sorry about that. And then I'm going to figure out make y is equal to 0, and I'm going to have a negative 1/4 x plus a half plus a half. Well, that's a negative 1 equals a negative 1/4 x. That means x equals 4. So this is 4. Well, this is, now the math is nice. 1 times 4 divided by 2 is 2. It's 2 again. If you got this, you got 1/10 of a point. Now, I needed to see work. Does everybody understand that? Christian, are you still looking at your grades?
I'm just confused about this pop quiz because I didn't even know about it.
I told you on Friday I was sending out a pop quiz, and I posted it, didn't I?
I thought you were referring to the Friday quiz, even though it didn't really come out of nowhere. Okay, it's just calling this a pop quiz.
Yeah, didn't I say it's a pop quiz and it's extra credit? I thought I said that, and then I think I posted it too, didn't I? Okay. I'm trying to be that way. Okay. Sometimes my wife says I didn't say that clearly enough, so I know I can be guilty. So if you got this and you showed your work, you got 3/10 of a point. So this section was worth 4/10. So 3/10 now up to 7/10. Okay, now this is any point on the graph. Would you agree? I could put 3 and 1/3. I could put 1/3 and 3. They're just reciprocals of each other. It's the reciprocal function. This is what we call in math an arbitrary point. And this part, I was really pleased. There are a lot of people that did this correctly. And this is a proof. But if I would have told you it was a proof, you would have freaked out. So I didn't. And so again, I know my point. So I know it's x minus a plus 1 over a. And I have two examples I can kind of follow, right? And I have to figure out the slope. And the slope is still this. And what am I going to put in there? I'm going to put in a. Now that's a constant. And when I was a student, that drove me nuts because I thought it was a letter of the alphabet, right? And so is x. And x is a variable, but a is a constant. So what's going to go here? Negative 1 over a squared. And that's the equation of my tangent line. I'm still going to need to know these points. So the first thing I do is I make x equal to a to figure out the y-intercept. So y equals, I make x equal to 0. So I have a negative 1 over a squared times, if I put 0 in here, I get negative a plus 1 over a. And if I simplify that, this is over 1. I believe I get 1 over a plus 1 over a, which is 2 over a. So this is 0, comma 2 over a. And then I'm going to make y is equal to 0. And I'm going to have a negative 1 over a squared x. And I'm going to multiply these two, and I'm going to get plus 1 over a plus 1 over a. So this is 0 is equal to a negative 1 over a squared x plus 2 over a. So now I get negative 2 over a, and I got negative 1 over a squared x. So I'm going to multiply by the reciprocal, which is a negative a squared, and I'm going to multiply this by a negative a squared. And I get 2a here, and that's equal to x. So this is 2a. Well, it's the same thing. It's going to be 2a, 2 over a times 2a over 1, obviously. A's cancel up. Oh, I got to divide that by 2, right? Base times height divided by 2. And I get 4 divided by 2. And it also gets an area of 2. In other words, any triangle you create from there will always have an area of 2, which kind of blew my mind when I was going through on my bike ride. Well, that's kind of cool. And then I picked a whole bunch of other graphs to see if it would work. I could only get this graph to get it to work. So I thought I discovered something, but I didn't. So if you got all of this, that was 5/10 of a point because it's far more general, right? And if you got this part right here, you got 1/10 of a point. This work is the other 4/10 of a point. Does that make sense? All right. So that was the extra credit. Bisters, any questions at all?
Have you graded all of those yet?
I believe so. Now there are some that, and I think you'll see online my what I scored, and some people, I can't put a 0 divided by 0 in on a spreadsheet. You understand what I mean? Into the grade book. So if you didn't get any points, I just left it empty. Doesn't mean you're not going to, there'll be another take-home pop quiz. I kind of liked it. Maybe I'll make it a little bit bigger font and when it's due. So maybe I'll make it due 8 a.m. on a Monday and start 12:01 on a Sunday. I don't know.
Mine's blank, and I definitely got some of those answers right.
Yeah, well, then I have to figure out what I did wrong. I would say it's me and not you.
Okay, sounds good. Thank you.
I actually remember correcting yours, and maybe I'll just go back. My guess is you can go see my score on there, and but I'll go take a look when I'm done with class. Okay.
Okay, thank you.
Yeah, I might have, because I try to go through these fast, and I hate to say it, I botch up a lot of times. So okay, did I give you guys 2-3 notes? Because that's where we're started. Remind me to give you guys the 2-4 notes because they're hot off the press before you leave. We're not going to do them this week. We'll do them next week. Okay. But then you have them. Okay. I'm trying to be ahead of time. Woo. Jacob Peters, do you have these notes?
I don't think so.
Jack, do you have these notes?
No, we didn't get those notes.
You'll get them tomorrow.
Okay, sounds good.
How did you guys not get them? What did I'm? Yeah, I must have screwed up and didn't give them. I'm sorry. Jacob, why do there's a certain group of guys that just like picking on you here? Are they your friends?
Yeah.
So anyway, if you look here, there's a pile of these. I'll give these to you guys tomorrow because we won't finish all the notes today. You know what? Zach, don't get up and get these notes. I will bring them to you. Okay. Why? Your foot is green. That's why you're. Zach, have you thought about breaking your other foot, making that gold? That'd be pretty cool.
That would be cool.
Or how about having a gold shoe?
That would be sick. Yeah, then I wouldn't be able to hop around. Oh.
All right. So what we're going to do, we're going to head towards something called the product rule. And you may want to take your pen or pencil and make some type of asterisk, meaning, holy buckets, I got to know this. In fact, I got to start writing on my windows. This is one of the fundamental ideas of taking the derivative. This is what you should know now. First of all, you should know this, that if I have something that looks like you you have some coefficient here. You have x to the nth. And when you take its derivative, it's going to be this constant times n times x to the n minus 1. This is called the power rule. Okay? And all it is, it's multiplication and you subtract 1. The next thing you should know is if you have a function and it's the sine of x, its derivative is the cosine of x. The other thing you should know is if you have a function and it's the cosine of x, its derivative is the negative sine of x. So you should know at this time 1, 2, 3 things. And you should know that if I have something like this, let me call it h, and I'm adding 2 functions, oops, or subtracting 2 functions, it doesn't matter. H is going to be, the derivative is going to be the derivative of those added or subtracted. Example. Let's say h is of x is equal to x cubed plus 2x minus 7. Noah, this derivative would be what? Noah McDonald. I gotta remember I got 2 Noahs.
3x squared
Plus
plus 2.
plus 2. Perfect. Bingo. You're done, right? No limits, right? It's not that we're going to forget about limits, but we're going to use them because this is efficient and we get it right. Okay? I see people nodding. Now, the question is, so I'm going to create some barriers here because I have a tendency to. What happens when we have a function and we multiply these? Okay? Well, let's just see. H of x is equal to x cubed times g of x, which is x to the 4th. All I did is, Ella, right? It's Ella? All I did was plug in what I said f of x was and what g of x was, correct? Can I combine those? Ella? You know what we get when we combine them? You need to speak a tad louder. X to the what? I think that's a 4. And this is a 3. Yeah, I know. My wife says, how in the heck are you allowed to teach? She said, your printing and handwriting are awful. She usually puts a word in front of that, and I'm not going to say it. 7. Perfect. Okay? So what would be the derivative of this? Ella, you're doing marvelous, by the way. 7x to the 6. Okay? Right? All right, so let's back up a little bit. Now that we know that this is a 3, what is the derivative of f? Cora. Remember, f is x cubed. Cora, Kaya,
Yes,
what's the derivative of x cubed?
3x squared.
Perfect, perfect, perfect. You want to try another one?
Yes,
What's the derivative of g?
4x to the third.
Perfect. So what would be the derivative of f times the derivative of g?
It would be 7x to the sixth
Ooh, how did you get that?
because it's h, the derivative of h.
Well, no. Let's look at here. Didn't you tell me this was 3x squared?
Yeah. Oh, wait, you mean,
Didn't you tell me
I
this
did
was
that wrong.
4x cubed?
Yep.
What do you get? Do you get 7x to the sixth?
No, you don't.
What do you get?
You get 12 to the fifth.
12x to the fifth. These are not the same, are they?
No.
So what do I want to say here? The derivative of h is not equal to the derivative of f times the derivative of g. They're not equal. They are not equal, are they? It'd be nice if it was, because we like everything if it's nice. I mean, it'd be simple. Take the derivative of g, take the derivative of f, multiply them together, boom, you have your answer. But it doesn't work. We didn't get that. Well, maybe it's because I just picked a bad problem. Let me try another one. Darcy, h of x is f of x times g of x. F of x is 6x squared. G of x is 4x cubed. Tell me what h of x is.
24x to the fifth.
Perfect, 24x to the fifth. Darcy, what's the derivative of 24x to the fifth?
120x to the fourth.
Very good, very good. Did you have a calculator in front of you?
No.
No. Okay. Noah Jensen. You just make me smile. What's the derivative of f? I think you said 12x. Okay. What's the derivative of g? 12x squared. What's the derivative of f times the derivative of g?
124x.
You said 144 x to the third, correct? Perfect. So if I look at these two, they're again not the same, are they? They are not the same. The derivative of h is not equal to the derivative of f prime times g prime. I cannot do it that way. But Heidi, maybe I'm just picking bad problems. And you know that's not a lie. I pick problems on purpose, right? But let's pretend, okay? So here, Heidi, f is 3x plus 6, and g is 4x plus 1. So tell me what h of x is. We're going to multiply them, so we got a FOIL, right? I don't think Mr. Karsh calls it FOIL. I think he calls it the distributive property. And he's correct, but I'm kind of old school when it comes to this. So what do you get when you multiply these first two terms? Perfect. I think you said 27x. And then you said something else. Did you say plus something? Oops, I forgot my x. Plus 6? Okay, so what would this be the derivative of? What would you get when you took the derivative of that? (24x plus 27). Which kind of makes sense because this is a parabola, right? And when we take derivatives of parabolas, we get lines, right? Because the degree goes down by 1, doesn't it? Jack, what's the derivative of f?
3.
3. Isn't that like the greatest thing you ever saw? That's a 3 right there. Sometimes it looks like an 8, but it's a 3. What's the derivative of g?
4.
What's the derivative of f times the derivative of g?
12.
12. Well, that's not 12, is it?
No.
Yeah, you can't do this. Now, here's what's unfortunate, Zach. There will be a third of you that will do it that way. I don't know why, but it'll be wrong. Okay? In other words, the derivative of some equation that is made by multiplication is not equal to the derivative of those two. It can't work. You're like, what was it? Not even close, right? So what is the correct way? Next page. And I'm going to skip the proof for now, and I'm going to come back to that, okay? Nick, okay? What does it say on your shirt? Grange? Oh, Braves. Are they still in the playoffs? Are you a Braves fan? Noah McDonald.
Yeah, the Yankees got eliminated. I know.
Are you a Yankees fan?
Yeah, probably 3/4 of my family lives in New York, and
Oh, really?
kind of
Yeah.
just in the family. So,
Do you know who Ethan Galler is?
no.
Oh, he's a Vikings. He's a Yankees fan too. So I don't hold it too much against Jeff. Just
Yeah, I still like the Twins.
your grade will go down here or there. Just ignore it. I'm just kidding. Okay. So this is what you're supposed to do. Okay. So I'm going to do this proof later, but I'm not going to do it today. But I am going to do. Let's do the first one, where h of x, where was equal to f of x times g of x. And Kaya came up with the answer of it being, or somebody did, the derivative was 7x to the 6, correct? Right? And f was of x was equal to, if I go to the back page, x cubed. And g of x was equal to x to the 4th, correct? So this is the product rule. The derivative of h will be, first of all, I'm going to write down the first function. The first function was x cubed. So I write down x cubed. I just ignore it, okay? Then I multiply it by the derivative of g. Well, the derivative of g is 4x cubed. Plus, then what I do is I write down g, which was x to the 4th, and I take the derivative of f, which is 3x squared. So let's follow that again. Here's my first, derivative of the second plus the second times the derivative of the first. Let's see if this works. This gives me 4x to the 6th. Would you agree with that? Plus, this gives me 3x to the 6th. Would you agree with that? And lo and behold, that is 7x to the 6th. Again, I'll do this proof tomorrow. All right, Cole? You ready? Okay, so G is made up of two separate functions. Now, Bryn would say, I could just multiply those out and take the derivative of each. Correct, Bryn? And you would be correct. But we're going to learn a technique in which you can't do that, okay? So we're going to take the derivative of G. And Cole, you're going to take this one right here and you're just going to write it down. We're going to take the derivative of it, but we're going to take the derivative of it later, okay? Times, now we're going to take the derivative of this one. What is the derivative of this one? 4. That's all it is. So here's the first one times the derivative of 4. Plus, now I'm going to write 4x minus 5 because I've taken that derivative. It's already here, right? And I'm going to multiply this by the derivative of this, which is what? 4x plus 3. If, Ella, you get to here, you are guaranteed 7/10 of a point without doing anything else. Because technically, you are correct. Now, Nick, you got to do a little bit of algebra, okay, to get the other 3/10 of a point. Well, Cole's going to do it for us. So the derivative is going to be, what do I get when I multiply this? Plus, what do I get here? Very good. Minus 8x. Awesome. Minus 15. So my derivative now is what? Yeah, I got to write the x, minus 15. Perfect. Haley, you ready?
Yep.
Okay. H prime of x. I'm going to write x squared down first. And then you're going to tell me the derivative of cosine.
Sine. Oh, negative sine.
Perfect. Way to come back. Plus. Now I'm going to write the cosine of x. Okay. Times the derivative of x squared.
2x.
2x. So that means, and this is how I would want you to write it, a negative x squared sine x. Are you okay with that, Haley?
Mm-hmm.
Now, I don't like this at the end. I always put, because don't be a voodooist and multiply these x's together. You can't. Does everybody understand that? So my answer is going to be, the 2x is going to be first cosine of x. And then you're done, because you can't simplify that any further. Haley, okay?
Yep.
Okay, super. Gus. Number 3. What am I going to write down first?
3x.
You're going to write down 3x, because this really is 3x times sine x, correct? This is a different function than this. This is a line. This is a trig, wavy kind of curve, correct? So now you're going to take the derivative of sine. What is it? Okay, perfect. Okay, now remember, I'm just doing this right here, correct? I'm taking the derivative of this thing right here. Yeah, perfect. Times what? 3. And that 3 is going to go out front. Okay, you can't say the sine of 3x. That's wrong. That's a voodoo thing. Okay. So now we're done with this. Okay. What about this? What do you want to do? Just like this? Do you want to do this kind of stuff? Okay. We can, and you'll get it right. So you would write the 2 first. Okay, I'll do it this way. And then you would multiply by what? Yeah, the derivative of that though. Yeah. Okay, now. Okay, we're not going to write this down, but you're going to walk us through this, okay? You would write a plus sign, correct? Okay. And then you'd write what? We haven't taken the derivative of 2 yet, right? Here's 2. We took the derivative of cosine, right? So I should write cosine, correct? Times what? Which is what? Yeah. Does everybody see that? So when this is a constant, I don't have to do the product rule. Because when you take the derivative of a constant, you're going to get 0. You can do that and be okay as long as you know how to multiply by 0. Everybody laughs, but I'll have somebody write cosine times 0 and then write cosine because you're all stressed out, right? You could see that happening. When this is a constant, you only have to take the derivative of this and not do the product rule. That's like this. If f was equal to 2x, would you use the product rule on this? Or would you say simply the answer is 2? Right? If you did do the product rule, you'd write 2 times 1, correct? Plus x times 0, right? And x times 0 is 0, and you end up with 2. Everybody following my thinking on that? Are you doing okay on that? So the final answer to this, Gus, is equal to 3x cosine x. Are you okay with that? Plus 3 sine x. Are you okay with that? Minus 2 sine x. Are you okay with that? Is there anything else we can do? Or are we done? I always look to see if there's anything I can simplify. Because you know you got a picky teacher. You ever hear of takeaway? When I first learned how to subtract, they said takeaway. So I used to go home and practice on my brothers. I'd give them something and they'd be happy and I took it away from them. I said, now you have 0. Okay. It was quite enjoyable for me. They found it to be a pain. Okay. So there's takeaway here. Here I have 3 signs and then I'm going to take away 2 signs, correct? I'll be left with 1 sign. And you don't have to write the 1, right? All right. Okay. Next page. Again, there's a proof. I'm not going to do this one. Okay? I'm going to do it, but I'm going to do it later. You know, I'm wondering if I should do this. I'm thinking about how much do I have on the back? And I have 25 minutes. Let me look at one thing, okay? Be patient with me, Abisters. This is what I'm thinking about doing. I'm thinking about giving you a pop quiz. Are you guys okay with that? Christian, are you okay if I gave you a pop quiz right now?
Yeah.
All right, here it is. Jack, do you see this lined piece of paper?
Yeah, I can see it.
All right, good, because I don't trust these machines. I just gotta see if you guys see. Okay, perfect. And make sure you put your names on this when you. Well, actually, what you're going to do, Abisters, send me an email. Don't send me a chat because if I close the chat, it disappears. Send me an email with your score at the end, okay? And you're going to use the product rule. This is a product rule pop quiz. So make sure your name's on it. And make sure you show your work. Okay, there's one. Here's two. And I know there's other ways to do this, but you got to use the product rule. Otherwise, you won't get any extra credit points. And all righty. Go ahead and start. We'll give you about 10 minutes. You have 4 minutes left. Where'd you get that hat, Cole? Neat hat. Some guy from Iowa? Oh, okay. Oh, okay. Yeah, so you traded a hat for, that's kind of a nice hat. I kind of like it. So it was like a National Student Council convention. We have 1 minute, 20 seconds. Does anybody need it? Zach needs it. Oh, Zach, you got a broken foot. I understand. Where'd you get the backpack, Gus? They sell them at the Deca store? Your backpack.
I got it for Christmas.
Did you got it for Christmas? It's kind of cool. I already bought my Christmas present for me.
Yes, kids, that was weekend lunch.
Next period, you mean?
Yeah.
Are you getting me in trouble?
Me?
Yeah.
No.
Why does that not give me confidence? No.
You don't need to see him anymore. I just want to make sure he's doing all right.
Okay, I will check up on it. All right, stop. Nick, want to tell me what you got for number 1? Not sure?
Like, you want me to say?
Yeah, just start what you did.
All right, first, I wrote 3x minus 4.
Okay,
And then times that by 3x squared,
okay,
and plus
okay,
x to the third plus 5.
okay.
And then times 3.
Okay, so if you got there, this is worth 1/10 of a point. Okay? Then tell me what you did.
x squared
Okay,
plus 3x to the third plus 15.
okay, if you got there, give yourself another 1/10 of a point. You're doing well. Okay. Did you have a final answer then?
All right, yeah, then you could take out 3.
Yeah, I don't factor.
You don't factor.
No.
Let's-
Well, can you combine terms? You're right, you could
Oh,
take
all
out a
right,
3.
You got 12x to the third minus 12x squared plus 15.
Yeah, and if you factored out a 3 and had those 3, if you would have had 3 outside and had 4x to the third minus 4x squared plus 5, that's fine, but you didn't need to do that. So if you have this, you give yourself a 1/10 of a point. Okay? So that one's worth 3/10. Number 2. Who was I gonna pick on there? Somebody. Ari, are you there?
Yes.
Okay. You want to give number 2 a go?
Sure.
Okay.
First I just changed the square root of x to x to the 1/2.
Okay. And then lift it like this. Like
Yeah.
that? Okay.
Yeah.
Okay.
Okay. So then I said x to the 1/2 times negative 2x plus 1 minus x squared times 1/2 x to the negative 1/2.
Okay, perfect. If you did that, sounds like you did, give yourself a 1/10 of a point. Okay, what did you do next?
Next I got 2x to the 3 over 2
Yeah,
plus 1/2 x to the negative 1 over 2 minus 1/2 x to the 3 over 2.
so if you did that, give yourself a 1/10 of a point. Did you combine any like terms?
Yes,
Okay, what'd you get?
I got negative 2.5 x to the 3 over 2.
You combined these two, correct?
Yeah.
And you got, what did you say? I didn't hear you.
I said negative 1.5 x to the 3 over 2.
I get 3 halves. I get 2 minus a half is 1.5 or 3 halves.
Oh, the 2x to the 3 over 2, I had that as negative.
Oh, yeah. It is. You're right. I'm wrong. I dropped the negative sign. You're correct. God, I should never have doubted you. So can I write this as a minus 5 halves or a negative 2.5?
Sure.
X to the 3 halves.
Yep. And then I had plus 1/2 x to the negative 1 over 2.
Yeah. And right now, this is good enough. Does everybody understand that? At this moment, this is good enough. It's not going to be down the road, but right now, if you did that, if you got to there, you got 3/10 of a point. And I know there's a denominator and all this other stuff. Did anybody keep on? Ari, did you keep on going?
Yeah.
Oh, okay. I'll give another extra credit point. What the heck? I'm giving extra credit point away like it's candy corn. Okay. Halloween is coming up. So what did you do then?
So then I had negative 2.5 square root x to the 3rd.
Okay, I'll do this. X to the 3rd square root.
Yeah. And then I had plus 1 over 2 square root x.
Okay, did you stop there then?
Yeah.
Okay. Yeah, there's something I would have done a little bit further. Did anybody do anything different? Anybody come up with a single fraction? No one did?
I did something different.
This right here is the right answer this far? Or did she make a mistake?
I got that.
I don't, except for my mistake of forgetting a -2, that's
Yeah, I did it way around.
This is their, what? Okay, back up. Morgan, what's your question? Yep. Oh, because you gotta take the derivative of it. Okay. You could have written the square root of x here, left it like that. Okay, there's nothing wrong with that, but you have to have this derivative. Do you understand that? Having this 1/2 note tells you that when I come over here to take its derivative, I'm going to take that 1/2 times 1 and subtract 1. You still have to figure, and Ari just knew that, hey, I'm going to have to take this derivative down the road. I'm just going to write down what its exponent is. But if you chose to have the square root of x here, that is fine. But then over here, I better see its derivative. And if you wrote this 1/2 times the square root of x, instead of this, that's okay. Do you understand what I'm saying? Yeah, if you did that, that's fine. You guys got to be okay with if I say a negative 1/2 is an exponent, you guys got to know that that's the square root of x in the denominator, okay, and that I shouldn't have to say that every time. Does that answer your question, Morgan? Okay. Okay, so I'm going to go through the remaining 2 tomorrow so you can get so hold on to these. Abisters, do you got that also? Dominic, okay?
Sounds good.
Okay. All right, we're going to stop. I got to give these guys the 2-4 assignments, okay? So we'll see everybody else tomorrow on the flip-flop because tomorrow's a gold day.